All right, my friends, let us go ahead and begin on this next one here, which is calculator active. It's question number 1, calculator active. Now, you may not have a calculator with you, but nonetheless, I think we can at least be able to get started on being able to learn how to set these kind of questions up here. All right, so we want to find the area of the shaded region here, right? We want to find the area of the shaded region, which is calculator active. So how do we do this? Well, it may look funky, but remember, it's always going to be top curve minus bottom curve. So we do top curve minus bottom curve. Well, we're going to do the integral from 0 to 1, which is the point of intersection, which they told us. And it's going to be 2x, 1 minus x, right? Boom, boom. Subtracted by the bottom curve, which is 3x minus 1 square root of x. Boom. Put an extra set of parentheses around here, and that'll be dx. And that takes care of part 1. We want to find the area of the shaded region. This is calculator active, so we could go, we plug them in here. Y equals y2, hit second, quit, hit math, hit integral. Obviously your calculators are more fancier than mine. Boom, and you just plug them in, and we'll do y1 and y2, right? And hopefully we know our shortcuts, y1 minus y2, and we'll get what the area is. All right, let's go ahead and move on to the next question here, which says find the volume of the solid generated when the shaded region enclosed is revolved around the line y equals 2. So let me just go ahead and draw a line up here, which is 2. And we're basically rotating this across the line y equals 2, which is very similar to the previous problem. We're going to rotate this around like such, and we'll kind of go ahead and get started here. Well, just like we always do, it's going to be top curve minus the big curve. There it is. Subtracted by little r. So we get big R minus little r. Big R minus little r there, right? This will be the big R will give me everything I want, and the little r, well, even though this is hard to make sense of, we'll start with little r. Little r is 2 subtracted by, well, we need to get the length of f of x. Here's the length right here. We need to subtract it to get rid of that, so 2 minus f of x, which is the equation. Big R is going to be 2. Well, we're going to subtract g of x. Even though this may intuitively, this may be hard to visualize compared to the other problems, it's still the same when we're rotating around a positive y value. And so when we do this, we'll get pi from 0 to 1, big R, which is r minus g of x, that will take care and give us what we want, subtracted by little r, which will give us what we don't want, which is the hole that we're going to get when we rotate this about the line there. Now all we got to do is just put an extra set of parentheses here, dx, bam, plug it into our calculators, and then we're in business, right? Again, in our calculators, we're doing 2 minus whatever, I forget now. Oh yeah, 2 minus y2 squared subtracted by 2 minus y1 squared, parentheses around that, and then we're in business. Okay, good. Hopefully that takes care of that, and that may get this somewhat completed through, and I'll talk this more in depth. This is a little confusing, but let h be the function given by h of x equal kx 1 minus x. Okay, for each k greater than 0, the region not shown enclosed by the graphs of h and g is the base of a solid. So h and g is the base of a solid with square cross sections perpendicular to the x-axis. So we have square cross sections perpendicular to the x-axis. So very similar to f of x, right? We have some kind of square, obviously hard to visualize that's going to be a square in here of equal length, right? Because it's three-dimensional. But really, instead of a 2 here, it's just k, but we know it's going to be the upper curve. And it's a square, and we know the area of a square is L squared. Okay, and it's a square, right? So we just need to do top curve minus bottom curve. So really this is h of x minus g of x, right? This is the length of L, because I'm getting the top curve minus bottom curve. Top curve is just this new function. There it is. So there is a value k for which the volume of the solid is equal to 15, right? But do not solve an equation involving an integral expression that can be used to find the value of k. Well, if we know the cross sections are perpendicular to the x-axis and it's a square, we know this is going to be from 0 to 1. This is going to be h of x minus g of x dx. Oops, let me put another parenthesis. There it is. That gives me the volume, right? And what do we know? Well, we know the volume is actually equal to 15. So that's really it. We have the cross sections, the integral that gives me the square cross sections perpendicular to the x-axis, and we also know it's equal to 15. Now, if you want it to be more precise, then we can write it as 0 to 1. H of x is kx 1 minus x. This whole thing here, subtracted by g of x, which is 3x minus 1, square root of x. Boom. Extra set of parentheses is dx. Don't forget your dx. Let me just clear that up. Dx is equal to 15. Okay, if we have that information there, then we can figure out and solve what k will be. But we don't need to solve it. We need to set it up. And that's pretty much it, my friends. All right. Take it easy and